Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
rate of reaction, calculating rate, and analysis of some results. So, the reaction rate, or rate at which a reaction, is the speed at which chemical reactions take place. Reaction rate is defined as the speed at which reactants are converted into products. So the rate of a chemical reaction can be found by measuring the quantity of reactant used or the quantity of product formed over time, using two equations below. The quantity of a reactant or product can be measured by the mass in grams or the volume in centimeter cubed or by an amount in moles. The units of a rate of reaction may also be given as grams per second, centimeter cubed per second, or moles per second. So if we're looking at measuring the rate of reaction, the change in volume of a reactant or product can be followed during the reaction. So this method is useful when gas leaves the reaction container. The volume of gas can be measured using a gas syringe or an upside down burette or a measuring cylinder. So the change in volume of the reactant or product can be used in this way. So if we look at the diagram above, we can see that our reactants are reacting in a flask, and there is a delivery tube leading to a measuring cylinder which is displacing the water, and it's the amount of displaced water will be equal to the amount of gas produced. So if we're investigating reactions by looking at colour change, the classic one is reacting hydrochloric acid with sodium thiosulfate. So you'd use a measuring cylinder, add something like 50 centimetre of dilute sodium thiosulfate solution, place it in a conical flask on top of a piece of paper with a black cross drawn on it. Using a different measuring cylinder, add 10 centimetre cubed of dilute hydrochloric acid and swirl the mixture together and start your stop clock. So if you look down at the mixture, when you can no longer see the black cross, the reaction is stopped, and you can go and stop your stopwatch, and that will give you the amount of time that that reaction has taken. So the table below shows the students' results for an experiment with hydrochloric acid of lower concentration. So we're looking at calculating the mean value of X in the table. It would be 46 plus 47 plus 49 divided by 3. Right, we have not included the 30 because the 30 would be classified as an anomalous result. If we're looking to describe the results shown in the table, so the rate is highest for the first 40 seconds. So this is because there are lots of reactants. It drops after 80 seconds, and this is because most of the reactants have been used up by that point. If we look at what is the rate of reaction when 18 centimetre cubed product is produced in 60 seconds, we'll do that by 18 divided by 60, so the rate would be 0.3 centimetre cubed per second. If we're looking at what is the rate of reaction when 33 grams of product is produced in 3 minutes, it would be 33 divided by 180. Remember that we usually turn the minutes into seconds, which would give you a rate of 0.183 grams per second. And if we're looking at what is the rate of reaction when 7 grams of reactant is used up in 2 minutes, remember again, we turn the 2 minutes into seconds, so we're going to have 7 divided by 120, which would give us a rate of 0.058 grams per second. So the rate of reaction can be analysed by plotting a graph of mass or volume produced against time. So the graph shows this for two reactions. So the gradient of the line is equal to the rate. So you can see there that a fast rate will be very different from a slow rate. So the steeper the line, the greater the rate of reaction. So fast reactions are seen when the line becomes horizontal or finish sooner than slower reactions. If we are looking at actually measuring the rate of reaction from a graph, this is the following set of instructions that you need to follow, because you will need to draw a tangent against a certain part. So draw a tangent against the curve, then draw a vertical line and a horizontal line from the right angled triangle with the line from step 1. Read off the change in the amount of product, read off the change in the time, and then use those two numbers to go and calculate what the gradient is, which will be your rate of reaction. So in this example, the amount of product would be the difference between 42 and 34 grams, so that would be 8 grams. The time taken would be 1 minute. So remember, we turn time into seconds, so it would be 8 divided by 60, which would give you a rate of 0.133 grams per second. If in this question we look to calculate the mean rate of reaction between 0 and 50 seconds, that would just be 1.6 centimeter cubed per second. And if we're describing how the rate of reaction changes between 0 and 60 seconds, so the rate is greatest at the start, then it decreases, and finally the reaction stops as the reactants would be used up. If on this graph we look to determine the rate of reaction at 50 degrees centigrade when the loss of mass is 0.95 grams, so you need to go and use previous method and draw your tangent, which would give you 75 seconds. So you go and do 0.95 divided by 75, which would give you 0.0127 grams per second. And if we're looking at describing how the rate of reaction changes between 0 and 150 seconds, so as before, the rate is greatest at the start, it decreases at 75 seconds before finally stopping.
Thanks for watching.